The charge to size ratio of a cation determines its polarizing power. Which one of the following sequences represents the increasing order of the polarizing power of the cationic species? K plus, Ca2 plus, Mg2 plus, Be2 plus, right? Now, these are the two species. Now, four species basically. Now, the polarizing power, the species having more polarizing power will be the species which is having small size, right? If the size of the species is small, it will be having more polarizing power, and it is having, if it is having more charge, then also it will be having a higher basically polarizing power, right? So these are the two basic requirements for high polarizing power. If I talk about the size, we can if I talk about the size of these four species, K plus, Ca2 plus, Mg2 plus, Be2 plus, right? Now these three, Ca2 plus, Mg2 plus, Be2 plus, they belong to the same group, and beryllium is at the top. That means beryllium will have the smallest size, then magnesium, then calcium, right? So that means beryllium will have the minimum size, right? Then magnesium, then calcium, right? Now, what about potassium? Potassium is in the same period as calcium, and it is earlier than calcium. That means its size will be smaller, right? Size will be larger, right? So that means K plus will have more size. So this is basically the order of the size, right? So we get the order. Now the charge, obviously, almost these three species are having the same charge, right? So that means if I talk about the polarizing power, so beryllium will have the maximum polarizing power because it is the smallest and it is having 2 plus charge. So that means the order of polarizing power will be Be2 plus greater than Mg2 plus because of the size, and greater than Ca2 plus. Now potassium is having the highest size plus less charge as compared to all the three species. That means it is having the least polarizing power. That means option D is correct.